Okay, something new, something different, kind of getting into some mathematical items here in chemistry. And so we're going to start with teaching you how to cancel units and how to go from a unit that you don't really want that they give you into a unit that you do want. So let's say they give you liters, but you need milliliters. How do you convert? How do you convert a strange unit that you haven't heard about before, like moles? This is what we're going to go into today. And a strong student understands that if you understand how to go from a unit that you have to a unit that the problem is asking about, that can be very useful in this class and also in physics. And so in in this class we're going to be looking at, okay, the process. Are you canceling units? Can you track the units going from one unit to another? Can you show your work, basically? And this entire thing that we're going to look at, the thing we're most concerned about is, are your units canceling and do you have the right unit at the end? And so, very useful skill. We'll use it again and again and again. So, as we go through this, take notes, take good notes, especially over the examples, and then show your work, show units canceling, and that's going to set you guys up for success. So, I'm going to work everything through the slide presentation. I have on this page right here, I have all of the concepts that we're going to work through, and then on the next page I actually have the problem. And so we're going to start here, but I'm going to be working that problem in blue, where it says how many liters are in 2.5 grams of neon. So there's a problem, and we've got to go from grams of neon into liters. And so we need to use the factor label method to convert our units. Well, in order to do that, you need some conversions. Now, these are going to be provided. They'll give you a chart or a table, or they'll be in the problem. And so I have two conversions here, and these are conversion factors, and they're going to allow us to convert between different units. And we have one that says if I have a mole of neon, that's 20.18 grams of neon. I don't really need to know what moles or grams are. I know that 1 mole equals 20.18 grams. That's fine. Second conversion factor, I've got 1 mole of neon equals 22.4 liters of neon. Again, all I really need to know is that 1 mole is 22.4 liters. So the first thing you always do is you write out the starting number and the starting unit. So let's slide over to this slide here. I wrote out 2.50 grams of neon. That's my starting number. That's my starting unit. My unit is grams of neon. Then the X is a multiplication sign. We are going to link these conversion factors together with multiplication signs, and it is a math problem. And so when we're done, we will actually run a math problem to figure out what the final mathematical answer is. So step 2. Write out a conversion. So the starting unit is on the bottom of the first conversion factor. So what is a conversion factor? That is a conversion factor. It looks kind of like a fraction. It's going to have a unit on top, a unit on bottom. It is a numerator-denominator kind of concept. And so this is a conversion factor. And so why did I write it 1 mole over 20.18 grams instead of 20.18 grams over 1 mole? It was written this way because I start with grams, so I want that unit, grams, to be on the bottom of the first conversion factor. You don't need to know a lot of chemistry to know whatever unit you start with, if you don't want it, it goes to the bottom of your conversion factor. So that might say hot dogs. If it said hot dogs are going to go to the bottom of the conversion factor. It might say Christmas trees. If it said Christmas trees go to the bottom of the first conversion factor. It doesn't matter what it says. That unit goes to the bottom of the first conversion factor. Now, they have to provide you with a conversion factor, which they did. 1 mole equals 20.18 grams. That allows us to get started. Now, you're going to cancel units out if they're on the top and the bottom. So just like in math, think of it as things in the numerator and denominator are the same, they're going to cancel out. Well, same thing's going to happen with our units. And so we've set ourselves up for success here because the grams will cancel. Because the grams are on the top and the bottom of the conversion factor. Now, if you look, we have moles on the top of the conversion factor that we started with, but the problem doesn't want moles. The problem says how many liters. So we have to do a second conversion factor. Sometimes you can do 1, sometimes 2, sometimes 5, but we have to now get rid of the moles and go to the liters. Well, they gave us a great conversion. 1 mole is 22.4 liters. So if we go over here, now if you look, I put liters on top, 22.4 liters, and then the 1 mole on the bottom. So you'll see that grams cancel, top and bottom, moles cancel, top and bottom. So it's the whole idea of being on the top and the bottom of the conversion factor. Those units are going to cancel. All we're left with is liters and neon. And that's exactly what the problem is asking for, liters and neon. So if we go back, it says cancel units on the top with units on the bottom, the same units. And then it says continue adding conversion factors until you get what you want. Well, we want liters. It's on the top. That's where we want it. So that's where we would be done with conversion factors. Then you have to actually do the math. So numbers on top, we multiply. Numbers on bottom, we divide. I don't usually mathematically do anything with the ones because they're not going to do anything, but you could put them in your calculator if you want. But what I would do is once I get to this point, I've got my liters, I got my neon, it's time to do the math. I would type in my calculator 2.5, all right? Not going to write in units, obviously, just 2.5. Now, if you look at this last thing on the right, it says if units do not cancel, you've got a conversion factor upside down, or you've got just an incorrect conversion. So if they don't cancel, top, bottom, top, bottom, top, bottom, you have made some sort of error, and you need to go check that. Often the error is that you have flipped a conversion factor. So let's say I had 20.18 grams over 1 mole. It wouldn't cancel. It'd be grams on top, doesn't cancel, so I just flip it over. All right, math, here we go. I'd put in my calculator 2.50. I'd then hit divided by 20.18, and I would hit enter. I would then hit multiply, and I'd type in 22.4, and then I would hit enter. I would do that in that particular order, just hitting enter after each operation so that my calculator didn't get confused. Now, if you want to use parentheses, other things like that will work. This is just kind of how I would do it. And there's your final answer, 2.78. All right, so definitely want to, I'm going to try that on your calculator, see if you get it right. All right, let's see another example where you can kind of try one of these on your own. So we've got more examples. So like how many grams are in 2.56 kilograms of dog toys? So we're going to have to get rid of the kilograms and we're going to have to turn them into grams. And we've got a couple of conversion factors to use here. We've got 1 kilogram equals 1,000 grams. We got 1,000 milligrams equals 1 gram. So I don't think the milligrams are going to be super useful because the problem's not talking about that. So let's write 2.56 kilograms of dog toys down. And then we'll use that conversion factor where we can get rid of the kilograms and then turn those kilograms into grams. So see, I did 1 kilogram on bottom, 1,000 grams on top. Why did I put a kilogram on bottom? Because I want to get rid of it. So the kilogram is on bottom, 1,000 grams go on top. Now the math, you'll see that the units are going away. The starting unit, kilograms. So kilograms is on the bottom. That's really, really, really important. You should put a star by that in your notes. And so I'm going to cancel those kilograms. And then we're going to go ahead and do the math. And so the math here would be 2.56 times 1,000. And enter on your calculator, and you're going to get 2,560 grams of dog toys. Number 2, how many liters are in a 24-ounce strawberry milkshake? Do I care it's a strawberry milkshake? Not really. But I've got to get from ounces to liters. So, first of all, some of the problems can be solved with one conversion factor. Others are going to need more than one. This one is going to need a couple. So, I'm going to start with that 24 ounces, and I'm going to go ahead and cancel the ounces and turn them into quarts. Well, why did I put ounces on bottom? Because I want to get rid of them. Why did I go from ounces to quarts or ounces to a quart? Well, because that's the only conversion factor I had available with this data. So, I'm going to get rid of my ounces. I'm going to put them into quarts. Then I'm going to go ahead and cancel those quarts. And I'm going to turn them into liters. So see, I got rid of one unit. I then got rid of a second unit. I now have liters on top, which is what I wanted. So now I'm done. Now, one thing to look at is when you're going through these, yeah, you can look these up on the internet. You can do conversions that you find on the internet in calculators. I'm not really that interested in the answer. I'm interested in the process. So if I give you conversion factors, you need to use them. I want to see that process. All right. Okay. Here's a couple for you to try on your own. So I want you to pause the video here, and I want you to try to solve these on your own. This is your student practice. And so we've got a couple of problems here. One is a single step, one is multi-step. And so you've got the tallest person ever, and we're trying to figure out some different conversions there. So I've only got a couple minutes left on this one, so I'm going to pause this one here. You do the work, and then on the next video we'll come back and we will take a look at your answers.